So here we've got a special type of problem called the initial value problems, IVP, okay? So initial value problems. So let's just first integrate this function here. So y of x is defined to be the integral of 1 over x plus x dx. Okay, I'm going to divide and conquer here, meaning I'm going to turn this into 1 over x dx plus integral of x dx. Okay, so these are rules that we just need to know. All right, go back to your rule list in the previous video. The integral of 1 over x is that ln of absolute value of x plus c. And the other one is just the power rule, okay? Add 1 to the exponent, divide by it. Now, this is going to give you absolute value of x, ln, and then the second part here is going to get you add 1 to the exponent is 2, divide by 2 right there. And then don't forget your plus c, okay? So this plus c here makes it to where this is the general solution. Okay, so this is what we've been doing up to this point. We've just been adding a plus c to our antiderivative. And so now what I'm going to do is an initial value problem. And so what this means is for various integers of c, each of these antiderivatives is a solution of the differential equation. So now you're doing differential equations. And this differential equation is the derivative of y with respect to x equals 1 over x plus x. Now, is that true? Right now, what do I have written? Y of x equals ln absolute value x plus x squared over 2 plus c, right? Well, dy dx is the derivative of ln x, which is 1 over x, right? And then the derivative of x squared over 2 is 2x over 2. And the derivative of a constant is 0. So this is 1 over x plus x, right? So that means I can substitute this in for that right there. And I have 1 over x plus x equals 1 over x plus x. Therefore, this is a solution to the differential equations. Okay? So now you can go home and tell mom and dad, hey, I'm doing differential equations in calculus 1, right? All right. They're going to be like, all right, son, why don't you go outside and play with some dirt, all right? Or whatever. All right. So dy dx equals 1 over x plus x, all right? Now, if we are given additional information, namely an initial value, then we can find a particular solution that passes through the point 1 comma 2. Now 1 comma 2 for you ladies and gentlemen out there, what that means is the x value is 1 and the y value, the output, is 2 here. Okay, so it's implicitly understood that I input an x of 1 and it outputs of y of 2. So this gives me a particular solution. The particular solution passes through 1 point. And so if you think back to what we've done in the past, like whenever I integrated 2x dx, I got x squared plus c, right? Now, you think about x squared plus c, this is a parabola, okay? It's a parabola, and that c determines where it shifts up or down, right? But if I tell you, if I say there is an initial condition of y of, I don't know, 0 equals 4, then what that means is I have to pass through the point 0 comma 4, meaning now this can't be any c, it has to be the c that such that we pass through the point 0 comma 4. So that's why we call it a particular solution, okay? And then I would plug in 0, so my y of x would equal x squared plus c, right? I would plug in y of 0 equals 0 squared plus c, and then so the y value, the output y of 0 is 4, so that would tell me that 4 equals c, and so my particular solution would be y of x equals x squared plus 4, right? So that's the idea of what's going on there. So that's just, for instance, let's do it for this particular problem that we just found the general solution to. I want to find the particular solution for the initial value of y of 1 equal to 2. So I'm going to take the 1 and I'm going to plug it in everywhere I see an x. Okay, so everywhere I see an x, I'm going to plug in 1. And so what does this become? Well, y of 1 is equal to what? Y of 1 is equal to 2. Okay, the natural log of 1 is actually 0. And then 1 squared over 2 is just a half. And then I have my plus c. So if I solve this, I subtract a half from both sides. So 2 minus a half gets me a c equal to 3 halves. So what does that tell me? I'm going to replace c with 3 halves here. So I get the natural log of absolute value of x plus x squared over 2 plus my 3 halves here. Okay?